Okay, this is video number 1 for two variable inequalities practice for integrated 1. So I'm going to go through and follow these steps off to the side while I'm going through and solving these problems. Make sure you follow along with the worksheet, and then after this video concludes, make sure you complete the you-try problems. Okay, so the first thing that I want to do is I need to be able to graph the boundary itself. So if you take a look back at this inequality that's been given to me, I don't have the y isolated by itself, so I want the y by itself. So I'm going to go ahead and take this, and I'm going to leave it as an equal sign, because we did practice flipping the inequality symbol when it's necessary or if it even pops up. So at this point, I'm going to add the 4, just trying to get the y by itself to both sides. I'm going to go ahead and put my work down the side here. So it's going to give me 2y. I added, so that does not change the inequality symbol. I like the x to come first and then the constant, trying to get it ready for y equals mx plus b. Last thing I need to do is to divide by 2, but everybody is going to get divided by 2. I'm dividing by a positive 2. That does not flip the inequality symbol either. Now, 2 doesn't go in there evenly, so I'm just going to leave it with negative 3 over 2, but 4 divided by 2 is positive 2. Okay, now we're ready for the boundary. So the boundary has a y-intercept of 2, so I'm going to go up to 0, 2 on the graph, and I'm going to go ahead and plot that point. And then from there, I'm going to do the slope. So it looks like I'm going down 3, so down 3, and then I'm going to go right 2. And I'm going to go ahead and plot that point. So I'm just going to kind of work my way across the graph. Down 3, right 2, trying to get the points for my boundary. Down 3, right 2. Likewise, cross and up. Okay, so now all of those should line up. What I want to do now is take a look at the inequality symbol itself. You notice that the inequality symbol has an equal to part that I just highlighted in blue or underlined in blue. That's telling me that this boundary is going to be a solid line. So I'm going to go ahead and grab a solid line using my straight edge to connect the dots. Make sure that I put my arrows on the end, since this does technically go on forever. And now, if for some reason I made a solid line and it was supposed to be dashed, you can always just grab your eraser and erase little chunks of the line. Okay, now, method 1. So what you can do is you can test any point on the coordinate plane, so on the entire graph, just as long as it is not on the boundary. So make sure that you are perfectly clear on what side it's on. So I think I'm going to go ahead and test -4, 0. So right there, I just marked it in purple. So I'm testing -4, 0. Now we know that every ordered pair is an XY. So wherever I see an X, I'm going to plug in -4. Wherever I see a Y, I'm going to plug in a 0. Now I'm going to go all the way back to the original before I even messed around with the inequality. So I have 2y minus 4 is less than or equal to -3x. Now I'm going to plug in what I found, or what I'm testing. So I'm going to plug in my 0 for y, and I'm going to plug in my -4 for x. Now, I'm not going to move anything from one side to the other. I'm just going to do the math. So typing the left-hand side into my calculator, I'm going to get a -4. Typing the right-hand side into my calculator, I'm going to get a +12. And I'm going to ask myself, is this true? Is -4 less than or equal to 12? Yeah, it is. Absolutely. Which means where that point is located is a solution. Notice that from the boundary, I have to kind of go left and down to get to it. So all of my shading is going to be in that direction. I'm going to go all the way across the graph here. Now, another way that you could have done this, and this is the second method that I italicized off to the side, but you got to be pretty comfortable with this. We can go back, so I'll go ahead and use a different color here. Let's see what I've got. Okay, so I'll use this yellow color. Notice, looking back, so I'm going to look at the inequality that I'm boxing in yellow. Notice that the y is isolated on the left-hand side. That's important. If it's isolated on the left-hand side, I'm going to go ahead and I'm going to put my yellow mark anywhere. So I'll put it right here, just color-coded in yellow. You need to be able to read the inequality though. So this says y is less than or equal to. Well, if the y-axis goes up and down, less than is going to be down. So from there, you'd be shading down, which means all of the shading would be below the line. Notice that it still matches with the purple shading. So another method in how you can figure out what your shading is going to be. Okay, moving on to the next one. So question number 2. This one's a little bit trickier only because we're only have one variable. So if that's the case, you can either see it as it's a little bit more challenging because we're not going to be dealing with slope at all, really, or it's actually kind of nice because you don't have to deal with slope. So you'll notice that this is an x equals. So here's what I'm going to do. I'm going to go to the x-axis, and I'm going to locate the number -1. Then I'm going to draw a vertical line through that. So I'm going to go to the x-axis where -1 is that I just marked in orange, and I'm going to draw a vertical line through it. That's my boundary. But I neglected to take a look and see if this was supposed to be solid or dashed. So if I take a look back at it, oh, it looks like the inequality sign has no equal to part, which means this is going to be dashed. That's okay. I can fix this pretty easy. I'm just going to go ahead and grab my eraser, and I'm just going to erase chunks of this line. Okay, now you can test a point, or we can use the trick with the inequalities. You gotta be careful though, this one has an X. So I am going to go to the boundary. So I'm gonna put my yellow dot anywhere on the boundary. It's kind of where I'm hovering my pencil. And I'm gonna read the inequality to myself. I wanna make sure that the variable is on the left-hand side. So X is greater. Okay, so we're talking about X movement only. X-axis goes right and left. Greater values are going to be right. So bigger values are always going to be right. Notice that my yellow shading goes to the right of my boundary, which means my shading for this graph is going to be on the right side of my boundary. We could have also gotten the same answer by testing any point. Remember, you want to shade where the point is true.